All right, welcome everyone to the ThingWorx 8.1 technical training series. My name is Greg Leary. I'm going to be your host and moderator today. Special welcome to our partners who are joining us. This is the fifth in a series of trainings that we've offered on the ThingWorx 8.1 release. In the past weeks, we've covered Studio, Foundation, Utilities, Edge, and the cross-platform capabilities. Today, our topic is going to be on the new and improved connectors in ThingWorx 8.1. If you are a PTC employee, we've posted all of the previous trainings, the recordings, and the slides at the link below on the technical support calendar. If you're a partner, we've done the same for you. We've posted the training content out on the partner community. If you look for the post that announces the technical trainings, you'll see the links to the recordings and the slides there. And note that we've also added a new training on October 9th for you around ThingWorx Analytics. That was a question that came up on one of our previous technical trainings, so we've added that to the calendar. That's on Monday the 9th coming up. And in case you haven't heard, ThingWorx 8.1 was officially released last Friday on September 29th. Before I turn it over to our presenters, just a couple of housekeeping items. First is that we are recording this session, so we'll post it, make it available just like the other ones. Second is that we're going to stop after each section and take questions, so we'll go through the Azure IoT Connector, let the presenters tell you all about it, then we'll take some questions, and then we'll do the same for the ThingWorx for Predix. So how you're going to enter and ask your questions is that there is a Q&A panel within your WebEx. It's usually in the lower right-hand portion of your screen. So enter your question there and send it to us, and we have a panelist of experts that will be able to answer all of your questions. We will certainly do our best to cover them all on the webcast today. If there's any that we can't, that we need to follow up on, or we just run out of time, then we will follow up on those and get them to you. So with that, we're going to start our training. I'm going to turn it over to Ken Rollins, who's going to kick us off. So Ken, you can unmute yourself and take it over.
Thanks, Greg. Good morning, everyone. Thanks for joining today. What I want to start off with is just kind of level setting in terms of the new features that we're talking about in ThingWorx 8.1. This is an important set of functionality we'll be going through today and really delivering on the value of the overall ThingWorx platform from a standpoint of, it's important that you recognize the fact that our ability to source and contextualize data across these disparate data sources and then synthesize and contextualize and orchestrate business value through the eventual engagements to an end user, whether it's for a desktop app, mobile, or mixed reality, augmented reality through wearables, is what the ThingWorx platform is all about. And the key is that you need to be able to contextualize and source this data from these different sources in the enterprise, as well as model it appropriately. So what we're going to talk about today is two very exciting new features as we continue to work with strategic partners, Microsoft and GE. We're delivering value with Azure and Predix connectivity today, and we'd like to go through that in a little more detail. Greg, if you could go to the next slide. As we go through the new connectivity options today, it's important to think of it in the context of all the different disparate data that we can source into ThingWorx and contextualize appropriately. So in the case of the different examples today, they're slightly different in terms of the type of either connectivity or data synchronization we're doing with these other systems. But the key is really being able to deliver ThingWorx within these different architectures with partners like Microsoft and GE, and really take advantage of ThingWorx rapid application development, our our AEP functionality, and being able to deliver not only applications, but iterate on those applications by using the power of our modeling tools and all the different connectivity options that we offer. So not only would we be just sourcing content, from, say, connectivity with Azure IoT, but we can also marry that with data from your traditional PLM or CAD systems, as well as leverage the industrial connectivity we have with Kepware and others. So it's important to know that these are added values to different deployment models that you might have if you're a partner or a customer. And at the same time, by utilizing these non-ThingWorx data sources, you can really deliver value, still using the ThingWorx platform all the way through to that engagement layer that I described. But by being able to contextualize that third-party device cloud data, bring it into the Thing model, and then deliver value through the visualizations and the augmented reality experiences through ThingWorx Studio really provides an end-to-end platform experience, as well as leveraging analytics and other tools that we have within the ThingWorx platform. So the key here is leveraging ThingWorx in these different infrastructures. You can leverage your existing investment if you're a customer and or standardize on a preferred cloud infrastructure. We've previously delivered on ThingWorx with AWS connectivity. We'll be focusing on the Azure and Predix components today, but this is all part of our open platform strategy with ThingWorx, and it's important to highlight these net new features as different customers look to implement our solutions using different cloud providers as well as different connectivity options. And with that, I'm going to turn it over to Anjan, and he'll take you through our Azure connector.
Great, thanks, Ken. Anjan, you should have control now.
I do. Thanks, Greg and Ken. Let me share my screen. All right, here we go. Good morning, everyone. This is Anjan, and let's get started with the technical training for the Azure IoT Connector. So here's a quick overview of what this is. The ThingWorx Azure Connector enables edge devices that use the Azure IoT Hub SDKs to interact with the core. So the connector is essentially a server that bridges the ThingWorx platform with the IoT Hub. It provides a way to represent and connect your Azure devices with ThingWorx. This handles message routing for the devices that communicate through the Azure system, and it also handles message routing from the core back to the devices. So this diagram illustrates the connector integration. This shows how data flows from one or more Azure Edge devices through the hub to the connector and back to the platform. So the connector here translates messages from the edge devices to messages which the ThingWorx core can understand. The connector then forwards these messages onto the platform. So if you look at the diagram, except for the edge devices, the components of this entire integration can exist within the Azure cloud itself. Again, this is a basic figure which just shows messages that flows from the edge devices to the hub, which flows to the connector back to the Azure IoT storage. The storage can send it back to the connector and then forward it to the platform. Here are some of our current features. The scalable connectivity between ThingWorx core and edge devices. It's horizontally scalable by adding instances of the Azure IoT Hub connector to handle increased load. We have a configuration file to tune settings for the connector. The security here is the security for the connections to the ThingWorx core from the connector. And finally, we have a health check service, logging, and metrics collection. The health check enables the users to monitor the health of the connection to the ThingWorx core and the traffic it handles. And the logging feature provides detailed logs to help with troubleshooting. With the 2.0 release, we have some new features. First is support for device twin. An Azure device twin is a JSON document, that stores device state information like metadata, configurations, and conditions. The Azure IoT Hub persists the device twin for each device that the user connects to the Azure IoT Hub. Support for device methods. Device methods in Azure IoT Hub corresponds to remote services in ThingWorx. This actually allows users of ThingWorx to invoke remote services from the platform onto the Azure IoT Edge devices. Then we have support for blob storage. An Azure blob storage container can be set up as a regular file repository in ThingWorx. So as a ThingWorx user, you can view the contents of the Azure storage from ThingWorx itself. We have new support for file uploads and downloads. We have support for Azure IoT Hub device jobs. We have a demo that we'll show later. And then finally, we have support for messages with multiple property updates in one cloud device message. So the connector bundle, which you can download from the support site, has the following items. The core ThingWorx connection server with the Azure IoT Hub adapter. The Hub adapter handles translation of messages and communication with the Azure IoT Hub and ThingWorx core. Then we have the Azure IoT Hub adapter extension that supports the Azure entities in ThingWorx. The next one is the ThingWorx Connection Services extension, which provides the Connection Services Hub. This manages the communication between the ThingWorx core and the Azure IoT Hub connector. And then we have a bundle of demo entities, which we give with the zip file. We also have a very detailed guide available on the support site for the Azure connector. This goes over the entire installation and configuration sections. So let's jump directly into the demo itself. We have a couple of demo sets. I will do a quick run through of what they are before we show them. So the first demo set is going to be an appliance demo and a device twin demo. So all these demos are again available with the zip file, so you can take a look at them. So the appliance demo provides a set of sample entities for the Internet Connect appliances. So we have a number of features with the appliance demo, some of which are the telemetry data, which includes information to demonstrate integration with an internal database or a third-party database. The Hub enables users to invoke device methods on an edge device from the cloud. And these requests and responses are JSON documents and are limited to 8 kilobytes in size. For the device twin demo, as I mentioned earlier, the device twin is a JSON document that's persisted on the Azure IoT Hub. The device twin stores device state information, including metadata, configurations, and conditions. The device twin data is usually data that is updated infrequently, and it actually plays a role in logic that is used in the Azure services, such as queries and device jobs. So let me show you the first demo, and we can go from there.
Hello and welcome to the Azure IoT Appliance Demo. The Appliance Demo features a set of simulated internet-connected appliances, including a washer-dryer, a refrigerator, and dishwasher. And we're going to step through how to set this up and then focus on the new features that the version 2 connector provides. The appliances demonstrate a number of useful operations, including sending telemetry to platform properties, sending egress from the platform to the edge, invoking services on the edge from the platform. They utilize the device twin and demonstrate how to use the desired and reported fields, and also shows us how to upload a file from an edge device to the cloud. So we're going to focus on the bottom three because those are the new features that the version 2 connector has provided above the previous release. Okay, so we're going to start assuming that we have a connector installed. We've got the connector bundle downloaded and that it is running. And I have one here started up and connected to our hub. I'm also going to assume that you've got a platform running and that you have the Connection Services Extension 1.4.2 installed and the Azure Extension Package version 2 installed. Okay, so those check out. The next thing we're going to need to do is import the entities that are part of this demo, and we're going to get those from the Appliance Demo Platform Entities directory. It's called Appliance Demo Entities. Just import these. And what this has given us is some templates and storage thing for the demo. In addition, there's a data table that's created, but we're not going to focus on that in this demo. Okay, so now let's get over and install the actual application itself. I'm in the exploded bundle. That bundle has a demo directory, and inside that, several other demos, but inside the Appliance Edge directory, we have a bunch of scripts that support the demonstration. So first, we're going to check that we have most recent or a suitable version of Node and NPM. This is a Node.js application. So we've got version 6.9.4 of Node and version 3.10.10 of NPM, which should be sufficient. And then we're just going to do a simple npm install, which goes and grabs all our dependencies, including Microsoft's SDK, device SDK for Azure, and all the other supporting modules. Okay, so that looks good so far. And now we're basically going to do the first step. It's a two-step process. First step is provisioning the things on the platform. A couple of files control what things you're going to create and where you're going to create them. One of them is devices.json, and that just basically describes all the things that we're going to create. We're going to create a fridge, a washer, a dryer, and a dishwasher. And the other is a provisioning configuration file, which defines the platform that we're expecting to install these on and the hub that we are going to connect to once we fire these things up. So here I have all this already defined. Setting, I'm not going to go into setting these keys. They are available in the hub under registry read write policy. There's a whole list of policies up there on the hub. So actually, I suppose we can take a quick visit over to the hub, because I want to show that we don't have any things existing there. I'm currently looking at my hub in the Device Explorer, and I have no things. And I'm going to now run provision.js, provision.com, and devices.json. So this is going to fairly quickly set up 4 example devices: our fridge, washer, dryer, and dishwasher. So once these are finished, then we can go over to the platform. We can also have a look over here in the cloud, and they are now existing there. And we now see that they exist on the platform. Okay, so off to a good start. Everything's set up, and now we just need to start them running. That's the second script, which is simply start.js. All right. So starts up 4 devices. The one device that is active and just starts sending telemetry immediately is the fridge. The other ones actually are started via services. Okay, so I'm not going to go into too much depth about property ingress and egress telemetry. That's stuff that we had working before, but note that we've got data flowing over, and we also have values that we can set on the edge to turn on the ice maker and change some other values. We're going to skip right to the new features, which basically include device methods or what we call service calls. And we've got let me go over to the new composer, and we'll take a look at the dryer. And over here on the dryer, we've got services, and what I'm interested in doing is starting the dryer up. All right, and this service takes a couple of properties. The parameter names, I should say parameters. Parameter names are cycle type and cycle time, and we're going to use the normal cycle. We're going to fire this up for 20 minutes. Execute that. We go over to the edge. You see that test dryer is now started, and now it's going to start sending more telemetry. So that basically is implemented with device methods that Azure IoT supports, and we have mapped our service to that device method. Let's take a quick look at the code that actually is used to make that possible. So here's the dryer object itself and the constructor for that. You can see that the dryer, when it starts, it goes through a little rigmarole here, and part of it is calling this on-device method, where we specify the name of the service and the name of the JavaScript function that we want to call when that service is invoked. And all of these device methods take two parameters, the request object and response object. Inside the request object, if you have multiple parameters on your service, there'll be a payload property, and that property contains more properties, each one for each of the parameters that you're sending, and of course the values that go with them. So you can just read the properties that you've sent with this sort of syntax. You can do whatever you like with that. In this case, we're changing the cycle time and the name, and when we're all happy, we send back to the platform that we received that request okay, and send back a return code of 200. If you're not happy, if the dryer was already running, for instance, we would send back an error code of 500, and we'd say that it already started. Okay, so device methods are pretty straightforward and simple to use, and that pattern applies across, I believe, all of the SDKs that Microsoft provides for edge devices. Okay, so let's take a look next at the device twin, the next big feature that is provided by version 2. So, intent of the device twin, and we have exposed it in properties on our things, and I think I'm going to go over to the bridge thing, look at that one, because I'm going to start tweaking this one. These three properties, twin desired, twin reported, twin tags, are on all of our IoT things. And the intent of the device twin is to store configuration or state data that doesn't need to change too frequently. It's basically a JSON document. We've actually separated into 3 different distinct parts because they have different functionality. JSON document with a number of restrictions on, for example, the depth of the document. I believe it's depth of 5 keys maximum. The length of the key is restricted, and the key content itself is restricted. The total size of the document itself is also restricted, so you can't store a ton of data in there. The restrictions are detailed in our documentation and Microsoft's documentation. But essentially, this is a separate thing. It's not tied to any of the properties on our IoT things, and you should not use the twin for telemetry because for performance reasons, if you're going to be doing telemetry data, you want to use messages. Okay, so the first JSON property we've got is the twin desired field, or I should start with tags, I'm sorry, tags field, and essentially that's just local data. You can set whatever you like in here. property set, but at the edge, the thing is completely oblivious to this value. The services SDK or the backend SDK is the only thing that understands this. This field can be used in queries. We'll show a little bit in another demo about how their special SQL can be used to query things that have particular values in their twin. Okay, and then the other two fields have an active role in this demo. The desired and reported fields. Desired is writable from the back end, and the edge can listen to change events for twin desired. And what I'm going to do for our demo is change the temperature set point for the freezer and the fridge, and that will trigger an event on the back or on the edge, and then that information will be pushed to the reported field. Now, the reported field is read-only on the property. And we can see here that we've already got a couple of properties set in reported, serial number and the thing template. This is actually loaded when the thing started. Again, we're going to, when we set the desired temperature set points, those are going to actually flow to the edge and then back to the platform via the reported field. So real quickly, we're going to set a value here, and I've got a little snippet. We're going to set the freezer temp set point to, and the fridge temp set point to 44, and we're going to see that the edge listens to that change. Okay, let's go over here to the edge, and we can see that, yes, the device twin did receive a change, and that data is now reflected in the desired field, and it also, by virtue of the application, for the fridge, we've now updated the reported field. So now we know that fridge temp set point has changed. All right. So how does that work? Let's just take a quick gander at the code. And on the fridge, we can see that when we start the device, we actually grab this twin thing from the client SDK. The device SDK provides this getTwin method, and inside that we can set up a couple of message listeners, and we specify what property we're going to listen for, and we specify a function that's called when that changes, and the value that the property was set to is passed into that function. And basically all I did was log that out and then call another function on my thing to change the freezer set point. And same thing with the fridge set point. Okay, so then those functions are down here. This code just basically makes sure that we're not setting out of ridiculous bounds, and then creates a little patch document. And that little patch document is going to be used to update the reported field. So, and that's called here, and this is part of the Azure SDK. We update the reported field, passing in that patch document, and then we say that we've updated the device twin. Okay, and that gets pushed then to the reported field. Okay, so pretty straightforward, pretty powerful, pretty useful little thing. Again, if you're an Azure application writer, kind of handy to have these fields available for you. All right, I think that's about all I'm going to explain there. Last feature is the file upload feature. Let's say that our fridge has a tablet interface on it, and we can type or write, whatever we want into our grocery list. And we want that grocery list maybe to be transmitted eventually to a mobile application, and that would be, maybe part of that would be loading that into blob storage. Basically, the use case here is we're just going to take our, some data that's available at the edge and push it into the cloud where it could be made available to other things. Okay, so I have a service that enables me to upload a file on the fridge right here, and we just basically need to specify the name, grocery list.txt in this case, and that file is is available to the fridge at the edge. And I'm going to execute this. And I'm going to see that I've got some stat information on that file and that the upload was successful. Okay, I'm not going to go into exactly how this is configured. We've got a little bit more file repository demo to go later, but essentially we should see now inside the blob storage, inside a blob called file uploads, that we have a folder with our test fridge in it, and the grocery list has now been uploaded. Okay, so the grocery list that I uploaded was this, eggs, milk, and cookies, and the one that's now on the edge is great. It's in downloads. Well, there you go. I uploaded it before. Eggs, milk, and cookies. Okay, so we successfully uploaded a file, and not going to dive into the code there too deeply. There is a file upload method here, upload file. Have a look at that to further understand how that operates. If you can't find this video later, the setup procedures for everything are documented in our README that accompanies the demo. And this concludes the demonstration. I hope that was helpful. Feel free to ask any questions, and thanks for watching.
All right, so that demo was from Ken Greiner. Thanks, Ken. So on to the second half of the demos. The second half was just going to showcase the rest of the features we have. So let me run through all of them before we actually show them. So first up, it's importing device from the Azure IoT Hub. And as the name states, it's just importing a device from the Azure IoT Hub. Next up is the device lifecycle and device twin change events. So Azure fires lifecycle events when a new device is either created or deleted from the hub. These events can be subscribed to in ThingWorx itself. So you can subscribe to these events in ThingWorx and then run services based on that. The next would be blob storage and file transfers. As I mentioned earlier, you could use the blob storage as a file repository thing in ThingWorx, but please note that the connector needs to be connected for the file repository to actually work. And the other note is that connectors for multiple Azure storage accounts cannot be connected to the same ThingWorx instance. And the connectors must be within the same storage account, which is configured in the connector's configuration. And then finally, we have the device jobs demo. Device jobs allow scheduling a specific action as a subset of devices. You can specify a time, an action, and a query condition for any devices. The maximum number of concurrent jobs is 1 for free and S1 tiers. For S2, it's 5, and for S3, it's 10. So with that, I'll pass the presenter to Matt Martin, who will be showcasing these demos. All right, Matt.
All right. Excuse me. Everybody hear me? No? Yes?
Yep, yes, you can.
Okay, I was just waiting for my audio to show up and mute stuff. Morning, everybody. As Anjan said, my name is Matt Martin. I'm a principal engineer on ThingWorx, responsible for the Azure Connector. I apologize in advance for any coughing or other related things. I'm getting over a cold. So with that, we will share my screen, hopefully. Okay, so this is the Azure portal. I have a couple of devices that I created for the purpose of import with the IoT Hub Explorer utility that Microsoft provides, which has a handful of useful functions from the command line. They also have a IoT Device Explorer, I think, which is a Windows-only tool, which I'm not too familiar with, but I think it has similar functionality. So I'm just going to briefly cover import. Import was something that we added and was covered in the previous update, which at the time was called Silver. We were in a metallurgical phase. So I'm just going to briefly go over that again for anyone who wasn't involved in that. So we got some devices to import. Go over to ThingWorx. And we look at the Connection Services Hub, the nexus of connector information. I know this, hopefully, I zoomed in a little bit, so this is a little cramped, but hopefully more readable. Although the service names are a little cut off, but that's okay, because we want to go to the import Azure IoT Devices service. You supply a pattern for determining what devices to import. I only want to import my import devices. You can supply a template which needs to descend from the Azure IoT thing template. It could be your own template defined from there. You can also add thing shapes if you'd like. And when we execute this, you get back an export ID, which is an Azure export. The only way to get the full list of devices out of Azure is to export them into a blob as a JSON file, and then you can read that in. So the export is an asynchronous action. So now I should have some new things. However, if you want to know when that's finished, then you can register for an event. We have a custom event that we created for this purpose. So import my subscriber. So we have a subscription, this particular event. This subscriber purely copies information from the event over to local fields. So if we look at the properties, we have properties for all of these things that we get back. The hub name that was imported, the count of things that were imported, the pattern that was used, the status of it when it happened, and if there were any failed or conflicting devices. I'm going to add another device or two. So we'll add a couple more devices. All right. Go back and do another import. We'll go back to our subscriber. Import happens pretty quickly. Yeah, so we can see that we imported from my hub. We were successful from import star. We had 5 that were imported and 10 that were conflicting because those devices already existed. And then there's a table that contains what those were. Same thing occurs if there's failures. You'll get those. You can look into those particular devices. That pretty much does it for import. I can pause here for questions if there are any.
I think you're good to keep going, Matt.
Okay. All right. Then next, we'll talk about lifecycle and twin change events. Excuse me. So, as was mentioned, Azure has events that they deliver for the twin being updated and for the devices being created or deleted. Those are things that are supported, but you have to add them into your hub. So the way that's done is by adding a route. So I've already added the route, but if you go to add a route, your name, and then you can choose twin change events or device lifecycle events. And for our purposes, you just want to route them. We accept them on the same event point that we get for everything else. You don't need to worry about the query string. So once you have those routes added, then you'll receive the events, and we send events into the platform. Okay, where can my events go? That's surprising. Okay, so we have there's a twin event demo that's actually included in our excuse me in our bundle. So should I import the appropriate thing? All right, so this subscribes to a device twin change event. And this, just for the purposes of the demo, this looks at the patch, which is what is provided, is a JSON document of the changes. This is whatever changes were supplied on the twin update, not just things that have changed. So if the twin update supplied a value that was already there, it will be in the patch. And I pull out a versions property from the desired section, and then I set those into the tags, and that will write the tags back out to the device. All right, so if we go to shell, I should probably add that device. I don't believe I added that device. All right, make a new device. I guess I already have that one. Okay. All right. So, is my terminal readable? I zoomed in on that, so hopefully that's.
Yeah, it's okay.
Okay. All right, so this, I'm using the IoT Hub Explorer to update the twin, setting a hardware and software version, which is what gets copied out. So that twin update happens, and assuming everything went as planned. Yes. So okay. So those values were copied over and written back out to the tags. So that's the basics of how you do the twin change events, and those are used a little bit later in another demo as well. similar vein, we have lifecycle events. The lifecycle events are, there's a created event and a deleted event. It also contains the twin document itself, if that's useful. Having some responsiveness issues. My session. There we go. All right, so I made another entity for the lifecycle events, which just subscribes to the lifecycle events that we trigger. We'll take a look at the servers real quick. So the source, the status is either create device identity or delete device identity. This is just set up to when a device gets created in Azure, it creates a thing in ThingWorx, and similarly when one gets deleted in Azure, it deletes it in ThingWorx. So go back to our terminal. And we create a new device in Azure. We have a new device that was automatically created. And similarly, if we go back and delete said device, okay, wasn't expecting that one. Okay, I guess I deleted it. Haven't seen that error before. Oh, really? Okay, okay, device is not there. Just still shows on there. Right, so similar to the twin events, those are fired from the platform or from the connector when we receive them from through the Microsoft's support for that. I think that's it for the change events. So I'll pause here for a second, take a look at the Q&A and see if there's any questions. All right, looks like we're good. Okay, so next we will move on to blob storage. So we added support for making a file repository that is backed by an Azure storage container. Have some blob storage here. If you're not familiar, Azure's blob service has its root entity is a container. So the storage account is configured in the connector. It's used also for the event processor host, which is a library that Microsoft provides for working with their IoT hubs. So it uses that to store checkpointing information so that it makes sure that it doesn't reread things it already read and can handle having multiple connected clients at the same time. So the storage container and storage account and this connector are configured in there, and then any other container that you have can be set up, and you can create a file repository based on it and work with it within ThingWorx. As Ken's demo had showed, there's also support for having a file upload, which is itself another container, although that one is a little special. It has to be, it's associated in the IoT hub to say that uploads go there, because uploads always go into one particular location, one storage container, and that's per IoT hub. So inside of ThingWorx, we have a template that we have created for storage containers, Azure Storage Container File Repository. In this case, I'm going to name it based on the name of the actual container. If you do that, you don't have to supply any configuration. If you cannot do that for one reason or another or don't want to, then you can supply the container name in the configuration as that mapping. This is the regular file repository, implements the file repository, standard ThingWorx file repository stuff, as well as there's a file repository shape, and then there's another shape with a couple other services. So you can use this just like any other file repository to upload or download files, browse directories. Look in the file system. I have one file that I put up there in my container just for sample purposes, which is a Docker Compose file that I use to run ThingWorx. You can access all the standard file repository services to put things up there and take them down. Possibly the most useful to many people is you can do a file transfer subsystem copy operation. So first I probably need to create a local repository. So I want to copy from firmware. Okay, so execute that copy. This is the same standard copy result you get. We fill in the fields that we can. Not all of them are necessarily applicable. Location ID and the like. So to a local repository. We can see that we now have that same file. And transfers also work in the other direction. I'm going to keep showing that just for the sake of not boring anybody. Well, yeah, we also file. The file repository stuff fires you'll get the same event that you can use to that you would use for file transfer copy operations. So all of the standard file repository services are implemented. One thing that is potentially of note, if you plan on transferring large files up into Azure through the repository, you'll probably want to increase the file transfer block size because for each block of those bytes, you're going to have another, you're going to do another write into Azure, so there's network overhead and the like with that. Having a larger block size should help with the speed of those transfers. All right, and I think that is it for file repository stuff. Check Q&A. And as Anjan said, this is backed by the connector. There's no, it's not a standalone file repository. It uses the connector for its operations and its configuration. Okay, on to device jobs. Device jobs were added recently into Azure for having a scheduled operation over a set of devices. At the moment, those operations can be twin updates which in that case can only update the you can only update desired or tags, which is a standard way that Twin updates work from a server side. Only the device itself can update reported, or you can invoke a device method. So along those lines, there's a demo in our that we supply for a firmware update use case, which is actually we took a Microsoft demo or Microsoft example of doing firmware update and took their code and with a few minor changes made it that demo work through ThingWorx. So there's some entities for that. All right, so the way the firmware update demo works excuse me, it's to trigger a download and an application of a firmware update for an edge device. And the way that's started by a device method, and it's coordinated via updates to the device twin that indicate the state and what it's currently doing. That's where it puts the URL for the file to download. That's the somewhat the use case of the twin is for that kind of information. So we have a template for an updatable firmware thing, which itself subscribes to a twin change event to actually update its values based on the reported information in Twin. So I create some things. Two of these. All right, so I have my two things created. So now I can connect those things. I'd already created these things in Azure, so I already have the appropriate connection strings for them. So those are both connected and waiting to receive the update method. While not necessary, and in our excuse me, in our demo, there's a mashup for triggering these one by one. But I'm gonna trigger them via a device job. Once I figure out what's going on, maybe into there we go. Okay. So for that purpose, I imported a thing that has a service for performing this particular update. It doesn't do anything particularly magical. The special thing that it does is to create a direct download URL which is one extra Azure-specific service that we added. The devices don't know anything about ThingWorx, so we need to generate a URL for the device to download the file directly from Azure and not through ThingWorx, because they may or may not have access to ThingWorx to do that, and we don't really need to proxy those bytes through ThingWorx for this case. Then we're going to schedule a device method job. So I'm going to set this up to go now. The query condition is Azure has a SQL-esque language for querying device twins and the like. So the main thing for this is device ID. You can compare it or do an in query. So I'm doing an in for firmware thing and firmware thing 2. The repo to download the file from is firmware. One file. So execute this, then get back a job ID. And you can see that both of these devices received the service call, and they are now downloading the file. You can see this is a file, a URL directly to the blob in Azure with a some security credentials that are good for, I think it's about an hour. Print out the files and then apply. So everything is completed. So let me go back and look at the properties on these. Let's see that, excuse me, the twin has been updated. So when we applied the various things, what the URI was, and that it's been completed. And then there's also some services related to browsing around jobs that exist on the Connection Services Hub. This is the job ID that we received. This is just status information that's provided from the Azure APIs, start time, end time, what it did. It has the payload that was sent to the method, query condition, the like, device count, succeeded count. If there are actual results for the method, you can actually look at job results. I remember the query offhand. No, I don't remember it. You can query by job ID or by other information to get job results. That really more applies for, it's good for device methods. Because device methods, if you call a device method, it actually returns any useful value, which the firmware update one doesn't. But the only way to get access to those values is by looking through the job results. But you'll only have job results. The job ID will only be able to search by it in job results if you actually have something that completed. If the job is failed or gets canceled or anything like that, then there will be no job results. But you should be able to find it by getting the job by its direct by its ID. You can cancel a job. However, you can only cancel a job that is not that hasn't started running yet. You initially schedule a job. It ends up in the queued state. At the time when the time passes that it was set up to run, it goes into scheduled for a small period of time unless it has to wait for resources. and then it goes into running. And once it's running, you cannot cancel it. So the job has a max execution time that you can supply, as well as timeouts you can specify a response timeout for service calls and things like that. But you can't cancel a job that's running. So if your response timeout is high and you have devices that are offline that are matched by your query condition, then you'll have to wait for the execution time to expire, which is of note. If you're in a lower hub, you can only have one job running at a time, and so you'll have to wait until that one is done before you can schedule another one. And I think that is about it for device jobs. If there's any questions on that or anything else? Any Q&A?
Nope. I think we're all set, Matt. Thank you for that. Did you have anything else, or did that conclude what you wanted to show?
No, I think that's all. That's it for me. I'm gonna pass the ball back to someone.
Yep. Thanks for the demo. Anjan, do you want to wrap up with anything?
Yeah, so that is it from the Azure Connector team. If there's any questions, we could possibly answer them right now.
Okay, there was a question on our configuration scripts provided or can be shared, and they are provided as part of the download bundle for the Azure IoT Connector. So you'll get some examples of that and everything that the presenters talked about in terms of the demos in that. We're going to go ahead and move on to the GE Predix, or the ThingWorx for Predix training now. If you guys do have additional questions for the Azure IoT Connector, you can feel free to enter those into the Q&A panel. We do have our experts on the line here, so they will answer those as they come in. At this point, Ken Rollins, I'll turn it back over to you to kick us off on the ThingWorx for Predix.
Thanks, Greg. Hopefully everyone saw, there's an extensive set of capabilities in this next version of the Azure IoT Connector. So looking forward to your feedback as you implement this on different projects, either as a partner or as an end customer. So the next piece we're going to go through is ThingWorx for Predix. ThingWorx for Predix deviates a little bit in terms of how we think about the connectors, such that the team actually delivered a set of components that we'll go through to really deliver an integrated solution, both synchronizing assets similar to the device twin synchronization on Azure, but implementing a ThingWorx side agent that implements on the Predix side to facilitate that integration. So we'll go through that in detail now. Again, these two features are currently available. They're with ThingWorx 8.1. We'll just want to highlight as well, we'll be updating the ThingWorx marketplace with additional content around both ThingWorx for Predix and the updated Azure connector, and the support and download sites have been updated with the posting of ThingWorx 8.1 last week. So all this material is currently available, and this training material will be also posted as an archive, as well as any of the slides or sample content we can make available to you as well. So with that, I'm going to turn it over to Vinay and the team to go through ThingWorx for Predix.
Yeah, thanks, Ken. Hi, everyone. Good morning. This is Vidyadhar Phadke, and I'm a developer on the ThingWorx for Predix team. And I'll go ahead and share my screen for now. Is my screen visible?
Yeah, we see it.
Okay, thanks. So Ken spoke a little bit about what ThingWorx for Predix solution does. So essentially, the ThingWorx for Predix solution allows you to represent your assets created in Predix on the ThingWorx platform, so that they can be leveraged for building applications based on that data. So that's one line explanation about the solution. Today we'll be focusing more on the administrative aspects of the solution and a little bit about the developer aspects of the solution. The end user will typically not interact with the system directly, but will interact with applications that are built on top of the framework. So first off, we'll take a look at installation and configuration. So this is again administrator specific material. Before we go into the actual details, I'll provide some background about what are the components involved, what Predix is for those of you who are not familiar with it. So essentially, the two components of the solution are an extension, which is deployed on the ThingWorx platform, and the other piece is a ThingWorx for Predix agent, which is essentially an Edge SDK client. The ThingWorx core can be deployed maybe in a cloud or on-prem. Similarly, this agent can also be deployed on-prem as well as in the cloud, but there is one third option that we'll look at, which can also be useful in some cases. So Predix basically is a IoT PaaS, which is built on top of Cloud Foundry. And typically in Predix, you have a user account, and that user account has one or more orgs. Each org can have a number of spaces, and within those spaces, you have different kinds of services. The services that we are going to be interested in today is the asset service and the time series service. The UAA service is essentially the authorization, or I mean the user account and authentication service, which is a OAuth 2 provider in Predix. So now the third option for deployment is essentially deploying the agent as as a droplet or a Predix application, which runs within the Predix cloud itself. And the advantage of that mode of running is that there will be very little latency between that application and various services. So essentially, the agent is a bridge between Predix and the ThingWorx core platform. So it can also be thought of as a out-of-process extension. So the first step that one would need to do after we get hold of the binaries is to install the agent. The agent is simply a Spring Boot executable jar file. So it can be simply run using the command java -jar. Of course, we need to provide some kind of environment variables to customize its execution. And at the minimum, you would at least need to provide the ThingWorx URL, the Predix app key for secure communication, and the name of the agent. So we typically want to provide unique names for our agents, and the rest of the properties are for tweaking the performance. Depending on what kind of system you are running on, you can tweak these properties to achieve better performance. This was about how this application can be run on a on-prem or in a cloud. But the other way to run it is to run as a Predix application, and to do that you would have to create a YAML file which has all the information that Cloud Foundry needs to run this application. You provide the name for your application and you say that this is a Java build pack because this is a executable jar file. You provide the correct version of the jar. Depending on your account, you can provide appropriate memory settings, and then you would provide a ThingWorx URL, the app key, and any other arguments you need to use. If you want to debug the application and to see what exactly is going on, you can also turn on logging using the -d logging flag. So let's go on and actually install the extension first. So the extension is installed. The next thing that we are going to do is run the agent, and it is going to be run just like a executable jar file. So this is what the command line looks like. Okay, since we assume that most of the applications have already leveraged the Predix platform and applications are built on top of it, it is more than likely that most customers are going to need some kind of integration between Predix and ThingWorx as far as the user logins are concerned. And for that, we have created a mechanism. It's essentially so basically the mechanism or the way to go about configuring this is a bit tedious, but we have created extensive documentation that shows step by step how one can go through it. The reason for the complexity of this process is the number of components involved. So there is ThingWorx, that is the service provider. There is a central authorization server that would be ping federate, and then there would be the identity provider, which in our case is the UAA service. So I'm not going to spend too much time on going through the process, but I will walk you through what the end result should look like. So once these steps are followed, if we open up the ping federate application or the server, we should see these options. There would be an IDP configuration on the left, service provider configuration. Within the IDP configuration, and if we look at the service providers, we should see ThingWorx in there. And if we go to the service provider configuration, we should see the list of all IDPs. There can be more than one or more IDPs in here, depending on how many UAA services you need to talk to. And once the setup is all complete, we should see how the administrator is able to log in. So the first thing that we would do is log in as an administrator. The administrator is also one of the users in the UAA. The administrator does not need to be provisioned on the ThingWorx platform. So since this is an administrator, we are taken right to the composer, where we would initially do some amount of configuration. So you open the ThingWorx SSO configuration page, and one of the important options here is the user modification enabled. We need this to be turned off because Predix does not or the UA does not really provide us with membership information on each login. So we don't want these users to get removed. The next thing that you would do is you would set up a home mashup for each of the users that are logging in from Predix, and you do that up there. And then you can configure which group all of the users provisioned from Predix are going to be added to. So out of the box, we create two groups. One is the Predix admin group, which is typically for administrators who need to create configurations, who need to add, remove things, and so on. So basically performing administrative kind of activities. And then there is another group that is the Predix user group, which is basically meant for all the provisioned users. Once users are provisioned, the sync is done, the administrators can actually move these users into groups that are appropriate for a configuration, so that the users can only see data that is relevant to them. That is pretty much all I had for the SSO configuration. So the next thing that an administrator needs to do is generate an app key. This will allow secure communication between the Edge Edge ThingWorx for Predix client and the server. This key would need to be provided on the command line or via an environment variable. The next step is to configure security and group membership. So in ThingWorx 8.1, the security aspects have been tightened quite a bit. So there are a set of permissions that we need to provide the admin group so that they can effectively administer the system. The main entry point for the administrators into the ThingWorx for Predix extension is the Predix subsystem. It has a number of methods. All of them have been documented. The first method that we would need to use is the add Predix integrator permission. This service essentially provides runtime and design time permissions to administrators on various asset entity collections, and it also provides permissions on some artifacts that are required for a successful synchronization. So let's go ahead and execute that. That's done. Okay, so that is pretty much about the installation part. Now the most important part is the configuration. So we have to get this right in order to do a successful sync. To add a configuration, we have a service called add configuration, and it requires a configuration ID and a JSON like the one shown here. The configuration ID, it is recommended that we use small names like this one because we have a feature that allows us to prefix all of the assets or entities created via the sync, and we want the names to be quite short. You might wonder that this is a large kind of configuration file, but most of the attributes have reasonable defaults and not all of them have to be provided. So I'll go through only the ones that are absolutely required. These can be loosely grouped into the following 4 categories. One is agent related. For example, the agent ID is an agent related configuration. And the way this works is we have agents that are running in the cloud or on-prem, and each agent is capable of running synchronizations for a number of configurations. So the agent can be used as a part of many different configurations. The next thing we'll look at is the authentication and connectivity. So Predix essentially uses OAuth 2 for authentication purposes. So we need to provide a OAuth URI, which we will use to get client credentials token from Predix. And we are going to assume that the client ID that we see here, the admin client, and has appropriate permissions on the various other services that we are going to use, namely the asset service and the time series service. So again, the asset URI service is not mandatory in for the US West deployment. It is usually this URL. The zone IDs are important because they do change with the account and the service. And then there is similarly a time series zone ID and a WebSocket URL. Then we look at the data related configurations. So these configurations affect what data is synced with ThingWorx. What data is sent, what data is filtered out, which collections are to be synced, which collection contain tags, and so on. We'll take a look at these concepts, the collection, the tag, and related things a little bit later. The next kind of configuration are the ones that are scheduling related. So essentially, once a configuration is created, we can start running the schedule. And to start it right away, we would set the auto start schedule to true. If we wanted to do that manually, we could set it to false. Then there are two kinds of intervals that tells us how often we need to do the synchronization of assets and how often do we want to synchronize the time series data. So in this particular example, it's 1 minute and 60 seconds. We also have the ability to disable one of those synchronization activities, so you can sync either assets or time series or both. The possible operations that can be performed on configurations: add, delete, update, enable, disable. So let's go and start up our client, which is already running. Okay. So before we start the actual demo, I'll just provide a little brief background about how Predix stores asset data. So Predix has, so all the material that has been used for this demo comes from the GE RMD app, which stands for Remote Monitoring and Diagnostics application, which is published on predix.io and is to be used as a reference app for building our own applications. So the Predix asset service is responsible for storing assets, and assets are nothing more than a JSON object, and each asset is stored in a collection, which is kind of like a bucket to store items of the same type. To allow validation of the assets that are being entered into the system, Predix also allows a schema to be provided for each asset. So what we are looking at here is a very simplistic kind of schema for classification objects, and it has a bunch of properties which are all string. Predix only requires that the URI be specified in every asset. But the asset schema or the schemas can get pretty complex and large depending on how much you want to validate the asset. So this particular schema for the asset is about 500 lines. The next thing we'll look at are collections. So in this demo, we'll be looking at 2 or 3 collections. So what we are looking at down here is basically the asset or the asset JSON, and you can see that it has a URI, it has some attributes like name, description. It also has some attributes which refer to other objects or other assets within the same collection or outside of the collection. And then the most important part is the time series. So Predix has a time series service, which is a separate service that can be used to store time series data, and it can be used independently of the asset service. But it is very important to link the time series service to the asset models for a useful application. So to do this, Predix allows us to create a tag collection, and this is essentially a definition of all the tags that are going to be used in any of the assets. So it has a name, a URI, and a data type, and then these tag objects are referred to within an asset. So we can see here that the asset tag has a reference to the tag URI, the tag crank frame compression ratio, and then it also has another piece of information. The tag, the name of the attribute is not very important, but it has another attribute which points us to the actual name of the tag in the time series service. So this is how the asset model and time series data are linked together. So now we'll go ahead with the demo, and we'll see the synchronization of assets from Predix to ThingWorx. And in this particular use case, the devices are still connected to Predix, just the data is being synchronized to ThingWorx for further processing. We'll go over this picture very briefly. So this essentially shows the left-hand side shows the physical asset model, or you can also think of them as instances. And on the right-hand side, you see the logical or the metadata model. And on top of each of the Predix artifacts, you will see the artifacts that the mapping of those artifacts in ThingWorx. So an asset group would be converted to a thing, assets are converted to things, and the relationship between them is expressed inside a network. So similarly, the attributes are converted to properties, and on the metadata side, we create thing templates, thing shapes for tags, and property definitions for attributes. So this is the data that we are going to use for the demo. We have 4 Predix collections: tag, asset, group, and classification. Tag collection is a kind of special collection, and we'll talk a little bit about that later. Along with these collections, we also have schemas that have been created for each of these collections. And we'll see how these are mapped to artifacts on ThingWorx. So all the assets that are contained within a collection are converted to things. So if we look at the asset objects, they are things. They will implement an asset template, which essentially represents a collection. So the asset collection is represented by an asset template. And then the schema of the asset is represented by a thing shape. And we call that thing shape a sync shape. And then individual objects within the tag collection are represented as thing shapes on ThingWorx, each having a single property. So now let's go and start the demo. We'll be creating a few schemas. We'll create a few collections. There will be some related objects, domain objects. There'll be the tag collection. We'll upload some time series data. And once the sync runs automatically, we will take a look at the artifacts that are created on the ThingWorx side. We will take a look at the time series values that have been propagated. We'll try to query historical data from Predix, and then perform some simple use cases like updation of assets, addition, deletion, adding new collections, etc. And the final use case is going to be update schema. So let's first go ahead and create a schema in Predix. To do that, I'm going to use Postman. Okay, so this is what a schema looks like. Okay. Okay, let's delete this. Let's get a new access token. Use the token and send the data. Okay, so the schema was successfully uploaded to Predix. Now let's go and create some assets. Oh, another hiccup. Okay, let's just close this browser and start over. So the tool that we are going to use to upload assets is called the Predix toolkit. We first need to log in as a client. We need the OAuth URI. and we are logged in. Now let's go ahead and create a few assets. Need to provide the zone ID. Okay, so the two assets that we are going to create for this demo is called the compressor 2016 and a compressor 2017 down here. We'll take both of these and upload them to Predix. Okay, let's re-upload the schema. Okay, so the asset has been uploaded. We can query to make sure that the objects are all there. So essentially for this demo, we have 4 collections of assets. One is the asset collection, the classification collection, the group, and the tag. So let's move on to the first use case. The first use case is about initial sync from Predix to ThingWorx. And to do that, we create a configuration, make sure the application is running. Select the configuration, and so in this particular configuration, we are going to be syncing these 4 groups. And we have our sync interval set to every 1 minute, 1 minute, sorry. And the time series sync interval has been set to 20 seconds. So let's go ahead and run this. So what this does is it basically creates a configuration, and along with that configuration, it would also create some additional artifacts, like one of them would be the value stream. Every configuration will have its own value stream, and this value stream is backed by a Predix persistence provider. So this persistence provider allows us to actually query information from Predix. And you'll see that a number of our entities have these special tags. So this one says that this is a runtime entity. Okay. So now let's check if the sync has completed. Okay. So you can see that the number of objects were created as a part of the sync. Now we are going to look at each one of these in a little more detail. The first few which end in dash tag are essentially the tag shapes. So for every object in the tag collection, we would create a thing shape, and each thing shape will have a single property, which is a log property. And the next one that we are going to be looking at is the sync shape. Now this is typically when a collection has a schema, the schema gets converted to a sync shape, and the attributes of that shape are essentially the attributes on the schema. So in this case, we have this bunch of attributes here. The next thing that gets created is a thing template. So every collection in Predix is represented by a thing template in ThingWorx. So we have here the asset collection, and again it has a tag which says it's created by sync. It extends the base thing template, Predix asset base template, and it will implement the shape that is specific to the schema for this particular collection. Now let's look at the actual things that were created as a part of this process. So there were essentially 2 objects each in the various collections. The first collection is the group collection. It has 2 assets, and they were converted to things. The classification also had 2 objects, and they were converted to things. And then the compressor the asset collection had 2 assets. We'll take a look at the assets in more depth now. So if you look at the asset, it implements the asset thing template, which is the thing template that corresponds to the collection. And in addition to that, it has a number of thing shapes. It implements a number of thing shapes. Now, each of them corresponds to a reference to a tag within the asset JSON. And another thing to note about the thing is the value stream that has been set on it. So this object was created as a part of the VP configuration, hence it has a VP underscore value stream attached to it. And this is going to come in handy when we actually query for historical data about the thing. Now let's take a look at the properties. So every asset will have can have some number of object level properties, and then it has properties that are inherited from the template. Some properties are inherited from the schema, or as we call it, thing shape in ThingWorx. And there are a number of properties that are inherited since these asset tags are referenced within the asset JSON. We can also see that these have already gotten some values, and these were actually fetched from the time series service. So we'll take a closer look at how that happens later on. For now, let's take a look at some of these attributes. So there is Predix allows you to connect an asset with another asset via links, and these links are essentially URI references. So when we detect these kind of links within collections or within assets, we populate them as associations on the thing. And here we see that this particular thing is related or is of type GE compressor cylinder classification, and it is also has a link to the Richmond refinery group. Another cool feature of this solution is the ability to determine parent-child relationships between various assets. And to take a look at those, we would go to networks. Every configuration will have its own network, and within the network we can see a hierarchy where the group is the parent of enterprise. Predix group is the parent of all refineries, and the refineries then have 2 compressor assets. So that was all about the initial sync, and this diagram just is a simple example of what is going on behind the scenes. The next use case we are going to look at is addition of new assets. So in this particular case, we are going to add one asset to an existing collection, and that asset would get synchronized to ThingWorx, and it will be put into the right hierarchy. So it will be put under the template, and the template already inherits the shape. So let's go and create this asset. So we are going to add an asset called compressor 2015. Take it and publish it to Predix. Now remember that the sync is essentially a scheduled operation, so it is running every 1 minute, and as soon as it detects a change in Predix, it will reflect that change onto ThingWorx. So right away we see the compressor 2015 asset was created, and we can see it's very much similar to the assets that we saw earlier. And again, the time series data has been populated. The next use case we are going to be looking at is delete. So if an asset is deleted from Predix, it is also deleted from ThingWorx. So we are just going to go ahead and delete the asset that we just created. We need to provide the URI. One thing that I probably missed to mention before is you can turn on the logs to see what exactly is going on in the system. Now we can go ahead and delete the asset. Now, as soon as the next sync kicks in, the object would be deleted from ThingWorx. This can take, so the time has been set to a minute, so we'll give it some time. So right now we are seeing that the time series synchronization is going on. Now let's see if the object is actually deleted from ThingWorx. And yes, it's gone. The next use case is an update use case, and updates can come in a number of varieties. You could be adding new properties to your assets, you could be removing existing properties, or you could be changing the data type of those properties. One thing to note here is that Predix does not allow deletion or change of properties at the schema level. Hence, it's not allowed. It cannot be done with ThingWorx as well. We'll take a look at this update of schema later on, which addresses the problem to an extent. So let's go and add a few properties. Let's first take a look at what the asset looks like right now. So this is a property that it has right now, and we plan to delete this one. And in addition to this, we want to add a few properties on top of it. Properties can come in different forms. So this particular property is a complex JSON object, and this will be represented as an info table on ThingWorx. Then there is a simple numeric and a string property, and we'll be updating the 2016 compressor. Let's take the object, upload it into Predix. Done. As soon as the next sync kicks in, we should see the object has been updated. Okay, so we already see that the property that was not a part of this asset has been removed, and in its place new properties have been created. So we have a numeric property, a string property with the right values, and we can take a look at what a complex JSON, how a complex JSON gets converted to an info table on ThingWorx. So it has the necessary fields. The info table has a nested info table inside. It has 3 arrays. These were JSON arrays, which are now represented as info tables. And that's a string array. So that is pretty much about updates to an asset. Let's move on to the next part, which is the time series. We already talked a little bit about how the time series stuff is organized. We'll now take a look at how the sync happens. So for this, what I'm going to do is I'm going to run a program which simulates time series updates to Predix. So this program is essentially going to write tag values to the compressor 2016, and we can take a look at what's present out there. So this basically shows us all the tags present in the system. The ones that are named 2015 apply to the 2015 asset, the ones with 2016 to the 2016 asset, and so on. Okay, so let's start running this. And let's take a look at the latest value of one of those tags. You can see that the value keeps on changing as newer data is being inserted. And currently I have the time series sync configured to run every 20 seconds. So as soon as the sync kicks in, it will update the values of the log properties. So essentially the value that is shown here is the value that was picked up at the whatever was the value at the time of this particular sync. And we can stop this process now. Okay, so this essentially is the latest value of the time series data, but to create the meaningful applications, we are also going to have to sometimes look at historical data, and you would typically build visualizations or mashups that display this data. To do that, everything on the ThingWorx platform has query property history kind of methods, and there is a method for each data type. In our case, all the properties are numeric properties, so we are going to use this query named property history. Essentially, we want to see the values of a number of properties as they vary with time. So we'll provide a start date. Any old start date is fine, and we'll provide a list of properties. You can see that these are actually properties on the thing itself. Now on. And there is this flag that can be used for sorting it in ascending or descending order. And this is how the various property values varied with time. And the entire list is not shown here, but it can be accessed via the API. So this was pretty much it on the time series part. So instance properties are updated on a periodic basis. Log properties are not stored in ThingWorx. They're queried as required using the query property history APIs. And finally, we are going to look at the last feature. This typically should be an infrequent operation, and hence it has a little bit of special treatment. The idea here is that we are going to change the schema, which on ThingWorx means that we are changing the sync shape. And once we change that sync shape, every object that implements it has to be restarted. In addition, we have to do some reconciliation. For example, someone created properties before the new schema was published. Then we need to move these properties back into the sync shape and remove it from the thing. And this kind of is a heavy kind of operation, and it might take time. So that is why this needs to be run when no active sync is going on. So we recommend that you cancel an existing sync or disable the schedule before you run this service. So what we are going to do is we are going to change the schema. So the current schema looks something like this. There are a bunch of properties here, and we are going to be adding 3 new properties: a string property, a Boolean property, and an object property. The first thing that we would need to do is upload the schema into Predix. Place this. Okay, it's uploaded. And then we would go and cancel the current sync if it is running. Once we are sure that the sync has been cancelled, we can go ahead and run the update schema. Here we need to provide the schema that we wish to update, and currently we want to update the asset schema and the configuration ID that contains the schema, and we'll run it. And let's take a look at how the schema got changed. So we can see that the new object property was added here, and the new Boolean property and the string property. So basically this is most of the features that we are introducing with the first version. There are a number of other features included as well, but those you can try out as you look at the documentation. That's it I had to share. So any questions?
Great. Thank you very much. Looks like we are good on questions, and we are at the end of our allotted time. Actually, one question just came in, so why don't you guys take a look at that while I make some final words here. Then if we can answer it, let's do that. If not, we'll follow up. But just first, I wanted to thank all of our presenters today for all of the excellent content and demonstrations. Thank you to our partners for joining today. We will make this recording available as well as the slides afterwards. I'll post it to the sites that we had shown earlier. Before we sign off, I understand it's at the top of the hour here. Vinay, did you guys have a chance to look? Oh, I see you just responded to the question here. So the question is, what happens if a Predix asset is renamed? And response is it'll be treated as delete and create. So hopefully that answered the question. Any panelists, I'll offer it up to you for any final comments before we sign off.
No, nothing from me.
Okay, great. We'll take silence as a no. And again, thank you everyone for attending today, and I hope you have a great rest of your day. Take care.
Thanks, Greg.
Thanks, Greg.